Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
All right, I'm very happy to welcome everybody who is watching this fantastic program. This is Olenjolai from Tanzania. I would like to take this opportunity to welcome all the national and international students into our fantastic program. And this is our national flag. I will be teaching you the beauty of advanced chemistry, and the topic of the day is called the organic chemistry. And we like to help serious advanced secondary students, and you are warmly welcome to join us from any regions of Tanzania, from any advanced secondary schools, from anywhere at any time, because we are here in order to make sure that we transform your life from the first point to another point. I will just to remind you the main objective that we'll be focusing in Tanzania online advanced secondary schools in square bracket OLENJOLAIM is actually to make sure that we train our students to think differently, and especially to think on how to solve real life problems. If it's your first time, just follow the instructions on how you have to register yourself. But our registrations, you just have to click the buttons of subscribe in order for you to receive notification from the official YouTube community whenever we publish a new video. So we are here, we are very serious. We believe that even our students also are going to be serious on this particular case. So today we have something new. We are going to teach you about laboratory preparations of alkynes, which is kind of revisions of what I've taught you in alkene. So right now, let me just spend a couple of the minutes to explain to you what I've written on the blackboard, and we dive directly into the session 24. So you're only welcome into Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM, and simultaneously we would like to welcome you into our official YouTube channel that called Tanzania Online A-Level City School in square bracket OLENJOLAIM. Similarly, welcome into departments of advanced chemistry, and the subject of the day is called advanced chemistry. The main topic is called advanced organic chemistry. The class is content for the pre-form 5. Pre-form 5 student, and even Form 6 students. Let's say pre-form 6 students, Form 5 students, Form 6 students, Form 5 students, reciters, QT students, grade 12 teachers, and the chemistries, not physicists. And we are still in chapter 2. We are about to finish it, chemistry. And chapter 2 is titled as saturated and the unsaturated hydrocarbons. This is session 24 about preparations of alkynes, and we are done with session 23 where we gave you the general introductions of alkynes and the nomenclature of alkynes. So today we'll be focusing on laboratory preparations of alkynes. So just to do the quick review, which is just a quick review or the quick overview. We say we have something we call the hydrocarbon. And these hydrocarbons is divided into 2 branches. The first one is called the saturated hydrocarbons. Saturated hydrocarbons, and then the other ones is called the unsaturated hydrocarbons. Saturated hydrocarbons and the unsaturated hydrocarbons. So saturated hydrocarbons, we have alkyne, alkynes, and then for unsaturated hydrocarbons we have also what? We have alkenes, and also we have what? Alkyne. So our point of focus today will be on laboratory preparations of what? Of alkynes. Just as a reminder, the functional group of alkyne is this Cn hydrogen 2n minus 2. So this is the functional group. Sometimes you can write as CH, then we have CH. So this is the functional group. This is kind of general molecular formula of alkyne. So you have a triple bond. The alkynes compounds should have a triple bond between carbon atoms, either one triple bond or two triple bonds. So let us dive into session 24, which is laboratory preparations of alkyne. So alkynes can be prepared in chemistry laboratory. By following, by the following methods. So the first one is called the dehydrohalogenases of vinyl compound. Dehydrohalogenation of vinyl compound. Dehydrohalogenations of vinyl compound. Hydrohalogenations of vinyl compound. So remember, the vinyl compounds mean that it's an organic compound which contains two adjacent halogens. So we say vinyl compound, this organic compound can undergo dehydrohalogenation reaction when they are treated with alkaline solution under the presence of alkyl amine. So these organic compounds can undergo dehydrohalogenation reaction when they are treated with alkaline solution and the presence of alkaline amino. Alkaline solution may be potassium hydroxide or sodium hydroxide. Maybe alcoholic. So the alkaline solution may be alcoholic. Alcoholic sodium hydroxide or alcoholic potassium hydroxide. General weight chemical equation is we have this in a compound compound and is treated an alcoholic. Sodium hydroxide, the product is alkyne plus ammonia plus salt plus water. So we focus on organic compounds plus water. So general molecular chemical equation, molecular chemical equation, have this no compound here. You see in the presence of what? Sodium amine. Sodium amine. Yes, sodium amine. So alcoholic, the sodium hydroxide, the presence of sodium amine. So here we are going to form alkali. Sodium X, 2 atoms of sodium, and then plus ammonia plus water. So try to think how the reaction took place there from just in there. Alkyne compound. Take a minute. Think. What if you've been asked to show the mechanism of forming that compound? What happened? Huh? How is this compound formed from crystal? Yes, chemistry. Try yourself. There's no need to evolve for somebody. So mechanism. So firstly, we have a vicinal compound. Then the first reaction will take place between sodium, and we still have here sodium amine. So here we have a bond between sodium. Remember, this sodium, the way it has been bonded, it has a bond with oxygen and oxygen bond with hydrogen. So listen. So the reaction here that will be taking place, we say that this bond will break down. So which one will be breakdown first? Okay. So these bonds break down because halogen is more electronegative more than carbon. So the halogen becomes a partially negative and carbon becomes partially positive. The first bond that will be breaking down. Okay? Yeah. The second bond, because our intention, or we need the final product containing triple bond. So the second bond that will be breaking within the carbon is bond between carbon and the hydrogen, because the triple bond will be formed between adjacent carbon. Okay? So from this first carbon, we have broken the bond between carbon and halogen. Fine. So this bond also has to break down. So the way it's going to break down between carbon and hydrogen, which is more electronegative, carbon. So the bond will be breakdown in this style. So partially negative, and this is partially positive. Again, the bond between sodium and oxygen break down. So this is partially negative, and this is positive. So you have what? We have alkyl group, we have carbon, we have what? This carbon is partially positive, we have a bond between carbon and hydrogen here, with this one, then with hydrogen here, and then with this one it is partially negative, but there is a bond with hydrogen, plus what? Plus X, which is partially negative, and then we have what? Plus hydrogen, which is partially positive, then plus what? Sodium, which is positive, plus hydroxide, which is negative. But in R, we still have what is sodium amine, which did not take part in the chemical reaction. So your partially positive, partially negative, the pi bond will be formed, but also this halogen will be forming a bond with sodium, and this hydroxide will be forming a bond with hydrogen to form water. So we have here an alkyne. We have a single bond between carbon and hydrogen. Here we form now a double bond between carbon and carbon. So carbon, hydrogen, hydrogen. So plus what? Plus sodium H. And then plus what? Plus water. So now we'll see the reaction of sodium what? Sodium amine. So sodium is bonded with nitrogen electricity.
On the second reaction, that carbon, the second carbon which is breaking between carbon and hydrogen, that carbon which is attached to hydrogen is already broken.
Pardon? This carbon?
The second reaction, yeah. Body cleavage.
Aha, so it means here we have 8. Is it? This is. Or if it to make confusion to you, this carbon still bonded with H, and this one is partial negative. So this is not hydrogen, so this is still H. Thank you. Okay?
Yes.
Then again, we have to think about breaking the bonds in the carbon to form another pi bond. Stop writing. How the bonds is going to break again. So the halogens, the bonds will be start breaking between carbon and halogen. So this is partially negative, this is partially positive. Okay? So here, the bond between carbon and the hydrogen will break down. So carbon is more electronegative, more than hydrogen. Okay? So with this one, this, so here we have double bond. Okay? Then here we have what? Always side. And here it is partial negative, here it is partially positive. Okay?
Yeah.
Then plus what? Plus hydrogen, which is partially positive. Then plus what? Plus Xe, which is partially negative. Plus sodium chloride. Then plus water. Plus, then the bond between sodium and amine will break down. Nitrogen is more electronegative. So sodium become positive and this one become negative. Okay? So plus what? Plus sodium ion plus amine. The amine is what? Is negative. Okay?
Yes.
So we form a secondary pi bond between this carbon and this carbon. So you have R carbon triple bond with this carbon, single hydrogen. So you have, so listen carefully. This halogen combine this sodium to form sodium halogen, and then become two moles of sodium halogen. Okay?
Yeah.
Then this positive hydrogen combined with amine, which is negative, to form what? Ammonia gas, which is nitrogen with 3 with 3 hydrogen. Okay? Let me repeat. We broke a bond between carbon and hydrogen. And then we broke a bond between halogen and carbon. So at this part, this carbon is electrophilic, is nucleophile, and this is electrophile. We form what? A triple bond. So instead of having partial negative, partial positive, we have another triple bond, right? Then this halogen combined with this sodium. Where did you get this sodium? It was in the bond between sodium and amine. Okay? 5. So sodium and X now form sodium X. So you have 2 atoms of sodium X. And this hydrogen, which was come from the organic compound, fissional compound, It is bonded with amine, which had two hydrogens, to form what? Ammonia, which are 3 hydrogens. So that's the mechanism of reaction. It's simple? Yeah, simple because I'm teaching. And I'm the one who is driving you. But when will be the one who is driving yourself, you'll see how challenging it is. So overall chemical reaction or equation. Say that we have alkyl, sodium hydroxide, and here we have sodium amine. Then we have sodium. That's water. That's amine. This is the example 18. Huh?
Yes.
Huh?
19.
Okay. Complete the following reaction. This mechanism. So let me leave this one as homework. I know some of the students here have tried this in homework 24. Let us do this, just for the purpose of understanding. It's not a difficult question. This is 1,2 dichlorocyclohexane. 1,2 dichlorocyclohexane. So this is chlorine, and then Sandagoro reactions with alcoholity, potassium hydroxide, with potassium hydroxide, okay, sodium hydroxide, and then we have sodium amine. Okay, so the solution for this problem, we start with cyclo or 1,2 cyclofluoro. So 1,2. So here we have a carbon bonded with chlorine and bonded with hydrogen, and here we have another chlorine and bonded with hydrogen. So the first reaction that will be taking place, we have also a bond between sodium and hydroxide. But we still have sodium amine. So the first process, here we have a bond between carbon and chlorine, so it will break down. Chlorine is more electronegative more than carbon. This is partially negative, this is partially positive. Partially positive. Okay? So partially negative, partially positive. And then, if the case, the bond between carbon and the hydrogens also is break down. So this becomes partially negative, this becomes partially positive. So my students have been trying, but they have been lying. So we have our cyclo compound, which still have one molecule of chlorine, but this carbon is partially negative, and then this one is partially positive. But here we still have, okay, so it's not a bond with hydrogen here. So plus what we have chlorine. This chlorine will combine with sodium to form sodium chloride. Then the hydrogens combines the hydroxide to form water, like this. And here we have sodium amine, which is going to break down. So the bonds is going to break down. So here, because we are partially negative, partially positive, what is going to happen, we are going to have a double bond. So the double bond will be formed here, which is pi bond, which is weak bond compared to C. Okay. Next, these bonds will break down. So I'm trying to do it in a summarized way compared to what I've done earlier, because you know everything I've taught you. So this becomes partially positive, and the bond between hydrogen and carbons also break down. These carbons become partially negative, and this one becomes partially positive. And the bond between sodium and amine break down. So this is partially negative, this is partially positive. So we have cyclo compound. Like this. Here you have partially positive, and here we have partially negative. So here we have hydrogens. These hydrogens will combine with amine to form ammonia. And then we have chlorine combined with this sodium to form 2 atoms of sodium chloride, like that. And then we have another molecule of water. Remember, the area of concentrations is organic compound, right?
Yes.
So here we have partially positive, partially negative. So here we are going to form a triple bond, like this. So you can write overall reaction. So overall reaction, we have 1,2 cyclo compound. So here we have chlorine, and here we have chlorine. And treat it in the presence of alcoholic, sodium hydroxide in the presence of sodium amine. Then the product will be cyclopine. Amine. Then the first method of laboratory preparation of alkyne. The second method that we can use to it's called the hydrogenations of alcohol, which is diol. So this method is not new. If you do remember what I've taught you in preparations of what? Preparation of alkenes. So the second method is the hydration. I taught you in previous session what the means of the hydrations of alcohol. And this is not every alcohol, but alcohol that has two atoms of alcoholic functional group. So it means that the hydrations of diols alcohol. So you see, diols alcohol can react with excess sulfuric acid form alkyne under the presence of mineral acid. Presence of mineral acid. So in general, where the chemical equation we have diol here we have excess sulfuric acid alkane plus water. General molecular equation is the functional group of diol react with excess sulfuric acid from alkyne has two molecules of water. This breakdown point 20. Huh? So complete the following chemical reactions mechanism. Okay, so we have that problem. So this is L, undergo reactions with excess sulfuric acid. So it's not a difficult question. You have just need to know the principles of breaking bonds and forming bond in organic chemistry. So this is our organic compound. We have a bond here, so let me just write the open structure for you to understand the process. We have the whole here. So whenever you find maybe reactions where the excess sulfuric acid is introduced, maybe on top of the arrow at the bottom, remember that this is the one of the reactant, right? In case that you have only organic compounds, and then the other, just like in this case, you see, this, the way it has been written, so you can note that you can define them, they are not taking part in reaction, but they are taking part in reaction, because this one cannot split itself. But in case maybe you have two compounds reacting, this can take a part, or can be a part of reactants, or it can be a part of reaction. But when you find that you have only one reactant, and then in most cases, but for these most cases that we can do the mechanism, then this one is a part of reactant. Okay, so take that note. I take that note. So here we have sulfuric acid. Usually I've told you that sulfur, information of sulfuric acid means that sulfur form how many bonds? 6 bonds. Yes. But in sulfur, what are the valence electrons in sulfur? Sulfur, it's in group 6, like oxygen, right? So actually, means the valence electrons for sulfur are how many? 6, right? Yes. So it lacks how many electrons to reach its octet state? 2, right? So it means sulfate can form a compound by using 2 electrons. But also we have sulfur dioxide. Can you think that sulfur dioxide, how many bonds does sulfur form with oxygen, atoms of oxygen? 4. But also you have sulfuric acid. So it means sulfur, it can form bond with 2 electrons. Sulfur can form bond with 4 electrons. Sulfur can form bond with 6 electrons. Why? Why sulfur can form those 3 different types of compounds, the same element? Is because of the principle of hybridization, which we used to teach our students in chemical bonding. Okay. So it says that there's double bond between sulfur and oxygen. Also here we have a single bond between what? Sulfur and oxygen, and a single bond between oxygen and sulfur. Here we have what? We have double bond with oxygen, and here we have a single bond with hydrogen. So 6 bonds for sulfur. That's sulfuric acid. So remember that whenever you're breaking a bond, something also has to take place at the same time. So our target or these reactions is going to give us alkyne. So this is the bond, here we have a single bond, this is the sigma bond. So to form alkyne, we need to break the bonds in the 2 adjacent carbon atoms, and some of the elements should be lost or should be removed in order to form pi bond. Okay, that the principle should be in your mind, that what you want to prepare. Okay, so if that's the case, we say that usually, remember that you cannot break 2 bonds in the same carbon. We have to break the bonds consecutively. It means that alternative. So these bonds will break down in this way. So here we have partially negative, and here we have partially positive. Okay? So again, the bond between carbon and the hydrogens will break down, and carbon will be more electronegative, partially negative, and this is partially positive. Okay? Here we are. So at this point, we say that, okay, fine. So what should we break about? So you have to break the bond between oxygen and the hydrogen. Okay? So, or even just a sulfuric acid, we can leave it there. But, okay, yeah, so the bonds has to break there. So then, next, what will be the product here? So you have this, then this guy, here you have partially positive, here you have the bond with hydrogen, you have the single bond, this is the single bond, here you have hydroxide, then you have what? Partially negative, plus what? You have hydrogen, partially positive, you have hydroxide, partially negative, you have hydrogen, partially positive, then you have what? Hydrogen sulfide. Hydrogen sulfide, which is partially negative. Okay?
On bond breaking, hydrogen and oxygen, the other part of hydrogen will also break. Bond cleavage happens.
I don't understand.
The bond cleavage.
In which compound? In this compound or this compound?
That compound of sulfuric acid. On the hydrogen and oxygen. Shown on one part, also in another part of hydrogen and oxygen also break.
Which party? Can you come and show me? No, don't break. That's why we have hydrogen here. We still have one atom of hydrogen sulfate. Okay, please reduce noises. So then, for that case, so this partially negative and partially positive form the bond. Form what? The bond. So now, if alkyne, then we have what? Hydrogen. So here you have that bond. Single bond is all. Hydrogen. Then plus water. Then plus what? Plus hydrogen sulfide. Salty plus hydrogen. Okay?
Yes.
So then we go into the next step. So the next step we have this. We have a single bond there, we have double bond. This single bond, then here we have hydroxide. That's what. So if we check our sulfur, we have a single bond, which is hydrogen. Then like this. Then we have, and here we have a single bond, which is partially negative. That's what hydrogen is partially positive. Okay? So next we say that this we broke a bond between this carbon and the hydroxide, so we have to, this hydroxide has to be hydrated. So the bond we break it this way, this becomes partially negative, and this carbon partially positive, and the bond between carbon and the hydrogen break it again, partially negative, partially positive. So the next molecule will be this one. So here we have partially negative carbon, we have double bond, and here we have a single hydrogen, partially positive, plus what? So you have hydrogen, but now we have two atoms of hydrogens, this hydrogen and this one. Okay? Plus what? Plus hydrogen sulfate. Ah, wait. Okay, so this one also has to break. So here also we have missing of one hydroxide, but we had a water molecule. And then we had the hydroxide, which we broke it from here. We have hydroxide, then this hydrogen and this one form two atoms of hydrogen. This is the sulfur trioxide, right? And this is our organic compound. You should not worry about how those inorganic compounds are being formed. Just focus on organic compound. Okay. So if you find that maybe breaking bonds is a little bit challenging to you, just know the organic compound should be formed. So here we have a triple bond. So our end product will be this hydrogen here, then plus what? So look. So, but here we have 3 atoms of hydrogen. Why 3 atoms? 1, 2, 3. Are we together? So 1 atom of hydrogens will combine with hydroxide to form water. So you have 2 atoms of water. You have 2 molecules or 2 water molecules, right? 2 moles of water molecule. Plus what? We remain with 2 hydrogen ions. These 2 hydrogen ions, one will be bonding, so it means that this guy or these oxygens will draw 1 hydrogen and the other also draw 1 hydrogen. To form what? Sulfuric acid. For the way the reaction is kind of sentence, you can do the mechanism without even involving sulfuric acid. But sulfuric acid should be a part of that. Because finally you have sulfuric acid again, and means that the hydrogens, for example, what does it mean? For example, here you broke the bonds between carbon and the hydrogen, and here you broke the bond between carbon and hydroxide. So this hydroxide and hydrogens can form water. No need the bond of breaking for sulfuric acid. But because it is a part of reactant, that's why we involve sulfuric acid in the mechanism. Are we together? Somebody saying we are not together. Why we are not together? Watch again this video if you are not together. Watch it several times. Hydroxide, hydrogen, and this is hydroxide. And the excess sulfuric acid. Okay, so once you have completed, you have done example 21, which is homework 24, and how to do the mechanism for this chemical reactions between 1,2 or between phenyl 1, just you can call it phenyl SN 1,2 diol. When T react with excess sulfuric acid, then you get alkyne. And even this one, the end product, one of the end products should be the alkyne. So you have to make sure that you are careful enough when you're carrying these processes. So the third method of preparing, of laboratory preparation of alkyne is called the hydrolysis of calcium carbide. Hydrolysis of calcium. Hydrolysis of calcium carbide. Hydrolysis of calcium carbide. So in this laboratory method of preparations of alkyne, we don't have the mechanism is not there. So we have calcium carbide within 2 atoms of carbon. That's calcium carbide. So you say that in calcium carbide, so you say when you say hydrolysis, it means when calcium carbide undergo or react with water, then it forms what? So it forms a sign. So calcium carbide, we have a calcium metal, and carbide is actual carbon, and when to undergo hydrolysis with water, then the end product will be carbon with triple bond. This is the sign. And plus calcium hydroxide. Plus calcium hydroxide. It's calcium hydroxide. So on right hand side we have two atoms of hydrogen, so we have total 4 hydrogen atoms. On the left hand side, that's why we balanced it by 2. We have 4 atoms of hydrogen, and on the left hand side we have 2 atoms of oxygen, and here we have 2 atoms of oxygen. 1 atom of calcium, 1 atom of calcium, 2 atoms of carbon, 2 atoms of carbon. So there is no mechanism required for that reaction, but just you have to understand that calcium carbide can react with water to form a sign. So this is the sign. That's the third method of laboratory preparation of alkyne. Reaction, okay, the first method of preparing alkyne is chemical reaction. Chemical reaction between alkyne alkalides. So alkyne can be prepared when the alkalides react to alkalides in the alkyl halide. And alkyl halide. So chemical reaction between alkalides and alkyl halides. So alkyl halides is not a new compound, but maybe the alkalides, it might be so I said that when alkalides, alkali salts reacting with alkyl halide, alkyl halides. So when alkalides salt, I'll give you the functional proof for that, reacting with alkyl halides, then the alkyne is increase the number of carbon will be formed. So when alkalides salt react with alkyl halides, then the alkali with increasing number of carbon, so increasing number of carbon will be formed. So we say we have alkalides react with alkyl halides. Product will be alkyne. This is what we call the general weight chemical equation. General weight chemical equation. So the product is alkyne plus salt. So this is another chemical reaction which increases the number of of carbon. So you have to pay attention, good attention with all of those chemical reactions which increases or decreases the number of carbons, because you know you need them in further problem solving. So, what is alkyl halide? First, alkaline. So, when you say alkalite, simply it means that it's the organic salt which contains triple bond, like this. So, this is metal. Okay, so that's its alkaline. So, whereby M stands for what? M stands for metal. So now we say the general molecular formula, general molecular chemical formula. We have alkyl halide plus alkyl halide, which is X. So the product will be formed in this. That will be the product. And the mechanism is very simple. Why is very simple? Because if, for example, you want to understand how the reaction is formed, we have alkyne here, then we have triple bond. We have a metal M plus other H. So the bond between a metal and carbon is more electronegative, so the bond will break this way, this becomes partially negative, and this becomes partially positive. Then the bond between hydrocarbons or carbons and halogens is more electronegative, more than hydrocarbons. So when this bond cleavage, so you have this way, so we have this compound, but this is partially negative, and then you have what? We have metal, which is partially positive, plus what? Alkyne, which is partially positive, plus X, which is partially negative. So this alkyne will be forming a new bond with carbon, while the metal form a new bond with halogen. So that's why we have Ara, triple bond with this carbon, and then here we have Ara. So in order to distinguish, we can have this one Ara dash, and here we have Ara dash, and here we have Ara dash, just to distinguish, and this is still Ara dash. So Ara dash plus what? So plus a metal and bonded with Ara. So the overall reactions, we have alkalite, when react with alkyl halide, the product will be alkyne. It's increased the number of 40 of carbon. So this is the overall chemical reaction. So nothing is difficult at all. So to end session 24, let us have homework 24, which actually will prepare you in the next session for session 25. This is example 22. So explain briefly 3 chemical reactions of alkyne. That's a question. You have to make sure that you solve it in order for you to get prepared for the next session. That will be session 25. So, ladies and gentlemen who have joined me online, this is the end of session 24, which has been titled about preparations of alkyne, where I taught you 4 methods that you can use to prepare alkynes in laboratory. You may even go in different reference textbook of organic, and you might find maybe more other laboratory methods that can be used effectively to prepare alkyne in chemistry laboratory. So again, I would like just to insist you that you can ask your questions in the comment section below, and you can give us feedback, you can give us your testimony. You can just tell us that what actually we've been doing to you, or how these programs has helped you. And again, in case you feel from your heart that you want to offer our living God, you are feeling thanksgiving for this program, you may send your sense giving through this telephone number 0759745331. And your feeling sensitive will be received with sense and will be used to pay the running cost for the future recordings or for the future multimedia work or for the future productions work of videos about advanced organic or advanced physics or advanced chemistry. So you're warmly welcome and keep enjoying, and you have to make sure also that you pass this information, so you share this information with your classmates in order for them to enjoy the beauty of advanced chemistry anywhere they are, and even at any time where they can access these contents or they in need of this material for them to master the beauty of advanced organic chemistry. So I invite you, join me in the next session, which will be session 25, when I will answer the homework 24, the last question for the homework 24, where I will be teaching about the chemical reactions of alkynes. And it's very interesting because I've taught you in alkenes, and some of the chemical reactions that we have learned in alkene, we are going to cover them in alkyne. But the only thing that which will be a little bit different is just having the triple bonds. But the reaction between alkynes and alkene is a little bit different, especially in terms of speed and in terms of the number of pi bonds allocated in the organic compound. So stay tuned, keep enjoying these contents until we meet in the next session. This is Olenjolai, and I would like to welcome you in the next sessions and see you in the next session. Don't miss it.
Mungu